Hi, chemistry enthusiasts. My name is Hanu.
And my name is Marthingi, and welcome to
H&M's Laboratory. Today we are going to demonstrate the process of elimination. And no, not the one you use in multiple choice, but the one in chemistry where two substituents are removed to form a double bonded molecule.
Also, we're going to talk about the big question that everyone came here for. Whether or not it makes a difference starting with the symmetrical versus the asymmetrical molecule for the elimination reaction.
So for an elimination reaction to occur, it can occur in either an alcohol or an alkyl halide.
But for this example, we're going to be using an alcohol to explain.
Specific conditions should be followed during the elimination reaction. So you need a catalyst, which in this case we are going to be using H2SO4 for alcohols, and you also need a temperature of 170 degrees Celsius. So this is an ethanol that is trying to undergo an elimination reaction. So here we have the OH and the H trying to form together to make water. And then this ethanol here will then form an ethene, which has a double bond between the carbon atoms. So the prior example was simple, as there's no doubt where the double bond could be formed since there's only one spot.
However, for alcohols with multiple carbons, it can get much more complicated due to the Satev's rule and where the double bond can be placed, hence creating a major and a minor product.
Now, you may be wondering, who the heck is Satov and why is he making things way more difficult than they need to be with rules? Well, he's actually making it much more easier. So, Satov rule is where poor becomes poorer. So this is where the carbon with the least amount of hydrogens will join with the OH and produce a double bond and water.
So in this case, we have butane-2-ol. And this carbon over here only has 2 hydrogens, compared to this carbon, which only has 3 hydrogens. So when you want to eliminate the OH and the H to produce the water, the carbon that's most likely to eliminate their H is this carbon over here. Since again, using the Satev's rule, poor becomes poorer. And since this only has 2, this one has less hydrogens compared to this. So again, the double bond's more likely to form in between these 2 carbons, compared to the first carbon and the second carbon, hence creating a major and a minor product. So it's more likely, and the molecule itself is more stable when there's a double bond formed between the second and the third carbon, compared to the minor product where the double bonds form between the first and the second.
Okay, now for an overall summary. This butane-2-ol is going to undergo an elimination reaction. In order to do so, it is going to have some conditions as concentrated H2SO4 and 170 degrees Celsius. This then forms a major product of but2ene, where a double bond forms between the second and the third carbon and water, and it will also form a minor product of butene, where a double bond is formed between the first and the second carbon and also has water.
Therefore, now that we have explained the elimination reaction, it is the time to explain the big question, which is if the symmetry of a molecule affects the elimination reaction.
And to answer that question, yes, the symmetry of molecules do matter, since it will determine where the double bond will be placed between the multiple carbon atoms and if the Satov's rule has to be applied, also known as positional isomers.
So in order for a molecule to be symmetrical, it has to have a plane of symmetry. So in this ethanol right over here, the plane of symmetry is located right over here. And so these two sides are mirror images of themselves. And if you rotate the molecule along the plane of symmetry, it still should be the exact same.
This molecule is asymmetrical because there is no planes of symmetry. For example, if you cut the molecule this way, there will only be an OH on one side. If we cut the molecule this way, again, there's only OH on one side. Hence, the Satov rule has to be applied to an asymmetrical molecule for an elimination reaction to occur. Therefore, the molecular symmetry determines if the Satov rule has to be applied, as stated earlier in the video. In an asymmetrical molecule, the double bond can be between different carbon atoms. Symmetrical alcohols turn into more stable alkenes. However, asymmetrical alcohols are less stable. Therefore, the Saitsev rule is applied to place the double bond between the appropriate carbon, thus making it the most stable it can be. Well, chemistry enthusiasts, thank you for watching our full of fun chemistry video.
Just to recap, in this video we went over the process of elimination reaction, how the Saitsev rule affects the elimination reaction, the difference between asymmetrical and symmetrical molecules.
Most importantly, the reason why you all clicked on this video to pass chemistry, how the symmetry of a molecule affects the elimination reaction.
And most of you already should have known this, but I'm making money off this video, so hope you learned something.
Come back again. Bye.
Bye.